I'm going to record so those people who are not here can see it later if they want to. Okay, right. So today we're going to do about solubility. Generally, we talk about solubility of salts like copper sulfate, potassium nitrate, sodium chloride, and their uses. I'm going to show you a presentation which I will send to your teachers afterwards in case they want it. No need, teachers, if you don't want it, you don't have to use it. And I will record this. I'm recording this so that you can see it if you want later. So here we are. I'm Teacher Mark. If you have any problem, raise your hand and I will repeat. If you have a question, raise your hand and I will stop and try and try to answer it for you. So what we're going to do is we're going to be the Challenge Age Department of Chemistry. Here we are. And we're going to look at solubility. And today we will look at several things. You don't have to write anything down, but this is what we will look at. We will very quickly look at definitions. I will show you one calculation of solubility, then I will give you one to calculate yourself. We will look at some solubility curves and what we do with those. We will do a couple of calculations there. We will look very briefly at precipitation and how we calculate that. And probably we will look at uses of the solubility curves themselves. So let's start with some definitions. You don't have to write them down, but if it's useful, you can. So the first one is solubility itself. Now, solubility, you know what solubility is. But if they ask you to say what it is in an examination, you have to say this. You have to say that, oh, sorry, these are the words which we're going to do. Solubility, solvent, solute, saturated. So solubility is the maximum amount, and you have to use the words which I have put in bold, the maximum amount of solute, which can dissolve in 100 grams of a solvent at one temperature, at a given or a particular temperature. This is really important. So it's the mass of solvent in 100 grams of solvent, sorry, mass of solute in 100 grams of solvent at a given temperature. It's really important that you know that. Okay, so what is a solute and a solvent? Well, they're quite simple. I think you know it already. The solvent is the liquid, and the liquid, the solvent plus the solute makes a solution. I think you know that. No need to write it down. And you know also that the solute is the thing which is dissolved in it. It's important to remember that a solute could be a gas, a liquid, or a solid. Normally, we are talking about a solid, but often it is a gas that we are more interested in. And the last word, which is more important, is saturated. Saturated is when no more solute can dissolve in that amount of solvent at that temperature. So you have to specify the amount of solvent. Is it 100 grams? Is it 200 grams? Is it a swimming pool? Is it, I don't know. And at what temperature is it? Hi, Kabiro. How nice to see you. So it is when no more solute can dissolve in a given amount of solvent at a given temperature. Now, if I had a cup of coffee, obviously Kenyan coffee, from Kenyan Coffee House in Nairobi, I would take my coffee and I say, I'm going to have some sugar and I'm going to put in sugar. And as I put in sugar, if I could keep the temperature the same, and it doesn't because as the sugar goes in, it cools down the coffee. But I had a friend when I was your age, and he liked 7 teaspoons of sugar in his coffee. 7. This crazy man. So he would put 7 teaspoons in and he would stir, but he never got all of the sugar to dissolve because it was a saturated solution. He could have put in 5 and it would have been the same sweetness. Okay, so you have to say how much solvent and what temperature, and that is the maximum amount of solute you can dissolve. Okay, so you need to then, when you write down things like this, you need to test yourself. So you need to go, okay, here are my 4 words. Think, what would I say? Just think now without looking at anything you have written down and tell your neighbor what you think solubility is, what solvent is, what solute is, what saturate is. Just spend 1 minute, talk to the person next to you. I will talk to my cup of tea and I will say, hey, cup of tea, I think I can define solubility. Solubility is just have a little conversation and let's see if you can have it right. See if you can define them now without looking at whatever you have written. Can you define them? Test yourself. Solubility, solvent, solute, those two are easy, but solubility and saturated, not quite so simple. How would you do it? So try that just now. So let's look back at them now. Let's look back at them now. There's solubility. Did you get that right? The maximum amount of solute which can dissolve in 100 grams of solvent at 1 temperature. Solvent and solute are easier, and then saturated when no more solute can dissolve. Okay, so let's move on. So this is calculating solubility. What we're trying to find is the mass of solute in every 100 grams of solvent at the temperature which they say. They often tell you what temperature it is. Here's an example. Find the solubility of KNO3, that's potassium nitrate 5, at 15 degrees Celsius using the following data. So here's the data. Here's the data. A student dissolved potassium nitrate in water at 15C until no more would dissolve. Their weighings are shown below. Well, they got a dish with some crystals of potassium nitrate and they weighed that. They knew the mass of the dish was 55. And then when they had added it all to water, they add the dish so that there are no crystals stuck on the dish. Okay, so you take your water, you add the dish as well to make sure you have washed it all off. So here are the details. So the mass of the dish and the crystals is 61. The mass of the dish is 55, and the mass of the dish and the crystals and the water, in other words, the solution, is 85. So what do we do? What do we do? Well, I'll show you this one. Oh, all right. So if the mass of the solution, so if the, let me just try and do it on here. If the dish and the crystals and the water is 85 grams and the dish and the crystals but without the water is 61, then the mass of solution Whoops, no, sorry, my apologies. Oh, hang on, I've got to change back. Sorry, I've got to go back one because I can't get my. Oh, why will you not come on? Come on. Oh, ah, sorry. Right, now I can do it. Now I think I can do it. Hang on.
Lodi.
Okay, right. So if the dish and the crystals and the water is 85, and the dish on its own, the dish on its own is 55, then if I take those away, I have 30 grams, which is the solution. Now, if I have the dish and the crystals, and the dish and the crystals is 61 grams, and the dish itself, we have already said, is 55 grams, then we know that the amount of the solid of the crystals themselves must be 6 grams. So if I have 6 grams in 30, whoops, sorry, I've got 30 minus 6, which is 24 of water, and I want it in 100, then I cross multiply. Okay, I'll just go through that again. Let's just go through that, just make sure that's okay with people. So I'm going to get rid of it. I'm going to hope to get rid of it again and go through it again. Come on, pen. For some reason, my pen is not behaving today. So let's erase that again, get rid. I'll come back to it. You'll see it. So we want it, the grams of crystals in 100, okay? So get the pen on again. Come on, pen. Oh, come on, pen. Why is my pen not working today? Come on, pen. Ah, right. So I've got my dish and my crystals and my water 85. The dish alone, in other words, without the crystals and the water, is 55. So it's 30 grams of solution. My dish and my crystals is 61. My dish alone is 55. So I've got the crystals is 6 grams. So 30 grams of solution contains 6 grams of crystals. So it's 6 grams in 24 grams of water is X grams in 100 grams. Can we mute, please?
Silver screen, kindly mute.
Thank you very much. So how do I do this? Okay, well, all I do is I cross multiply. So I say this is this. So X grams times 24 is 600 here. Okay. And that equals 600 divided by 24, which will be 25 grams per 100 grams. Okay. So we'll see if you can have a go now. I'll do it. If you can't, we'll find another example and see if you can do it. But you work out the amount of solution here, then the amount of crystals, and then you say, okay, if I have 6 grams in 24 grams of water, then how many grams is it in 100? That's what we're trying to do. Okay, here's one for you. Here's one for you. Here's one to try yourselves. Find the solubility of potassium nitrate again at 50 this time. At 50, uh,
No, I
some
want video. So who is your video?
guys, could somebody mute, please? I'm not sure who it is, but please mute.
St. Michael, St. Michael, kindly mute. St. Michael, kindly mute. Kindly mute from your side. St. Michael, kindly mute. Okay, thank you.
Thank you very much. Thank you, Michael. And St. Michael. Perhaps you are St. Michael, Michael. So here's one for students here now today. Find the solubility of KNO3, potassium nitrate, at 50 from the data below. So it tells you the mass of the dish and the crystals is 41.5. The mass of the dish is 15, so you can find out the mass of the crystals. And the mass of the dish and the crystals and the water is 71.5. If you can find out the amount of water, then you have it sorted. Have a go. Just have a go yourselves. If you think you have an answer, that would be fantastic. I'd love to see it. If anybody thinks they can do it, that would be marvelous. You would be a very clever student. Kabiro look like they are thinking about the answer. Who will get the gold medal today? Oh, Mathari mix. No, oh no. Kabiro, oh, Mathari mix. Whoa, Mathari mix is in with the gold medal, much the same time as Kabiro. Let's have a look, Kabiro. Let's have a look. Let me have a look, please, Kabiro. You're going to have to hold it stiller than that. Oh, hey, hold it again, please, Kabiro. Come on, have courage. 80, up a bit. 86.5. Do you think 86.5? Close. Nearly 86.5. Nearly. Very close. Slight arithmetic problem, I think. But anybody else? Come on, St. Mary's. Come on, Wamwini. Come on, compete. I know you're very clever. Let's see it. People at Kabiro, people at Mathari, don't let just one person answer. Make sure that you can answer it too. It's very important that make sure you can answer the questions too. Anybody else? I'm sure somebody else can do it. So to find the amount of solution, it will be the bottom number, 71.5, minus the mass of the dish. That's 71.5 minus 15. That will tell us the mass of solution. If I want a mass of crystals, that will be the 41.5 minus 15. Then I can work out the amount of water. And I think that the amount of water will come out as about 30, and the amount of crystals will come out as 26.5. So it would be 26.5 in 30. Hello, Silver Spring. How nice to see you. Good. Excellent. Did you get this? Have you got the answer? Let's see it then. Come on. Don't be shy. It's okay going, yes, 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 we have the answer, but I need to see it, huh? It's not 20, Wamoini. No, it's not 20. We'll go through why. I'll show you why. So the mass of water is the third number, take away the first number. So that's 30 of water. And so it's 30 of water. If it's 30 of water and it's 26.5 of crystals, then it's 26.5 in 30 is what in 100? And the answer, I think, came out as 88.3 or something like that. 88.3. Okay, let's move on. Let me just change my screen. So I'm going to stop sharing for a minute. Oh, somebody, St. Mary's, let's have a look. 80, a little bit closer. 88.3 is the right answer. Very, very good, St. Mary's. Well done, St. Mary's. So if you're not sure about this, if you look back later, if you look back at the video later, it will be on YouTube. You may have it on your tablets. You may have your teacher may have it. Your teacher can go through it and show you it. This is a question which comes up in the examination quite regularly. So have a go at it. Make sure that you can work out, that you can calculate the most important thing, which is solubility. Okay, here we go. I'm now going to go on, and I'm going to go on to do with solubility curves. Now, we found that in the first calculation that the amount at 15 degrees was much less than at 50. That is very important. I'm going to stop sharing just so I can tell you this. Solubility curves show us the maximum solubility at one temperature, at a set of temperatures, but each one has to be measured separately. What we are going to look at now is some solubility curves for solids. We are not going to look at solubility curves of gases, but you need to know something about them, so I'll tell you it now. In general, you will see that the solubility of a solid increases with temperature. Most, not all, but most increase with temperature. So solids dissolve better when it is hotter. If I have a cold cup of coffee and a hot cup of coffee, and I put sugar in both of them, the sugar will dissolve better in the hot coffee. Not surprising. Okay. But gases become less soluble as temperature increases. So solids become more soluble, gases become less soluble. You may know this. If you get a bottle of Coke and you have it in a fridge and you open it, it goes tss. If you get that bottle of Coke and you leave it in the sunshine for the day and you try to open it, you will end up with no Coke. because the gas will come out of solution and all the Coke will come out of the bottle. That is because the CO2, the carbon dioxide, carbon 4 oxide in the Coke only dissolves well when it is cold. So when it is cold, a little bit comes out. When it is hot, all the gas comes out and it takes out all the liquid. So solids normally more soluble, gases less soluble. Okay, let's have a look at some curves. Here they are. Just have a look at this for a minute. I want you to look at the shapes of the curves, what most of them are doing. Let's look at them. Here's sodium nitrate up at the top. It's directly proportional, straight line, directly proportional. It is very, very soluble, even at very cold temperatures. Do you see that? Even at 0.73 or 4 grams of NaNO3 can dissolve. Calcium chloride, CaCl2, a bit less soluble to start with, but becomes more soluble, look at that, over 94 degrees or so. You see that? Calcium chloride less soluble to start with. At 0, sodium nitrate, 73, 74. Calcium chloride, I don't know, 58, something like that. But they have the same solubility here at about 94. So some of them are straight lines, some of them are curves. Here's another straight line, potassium nitrate. Here's another curved line, potassium nitrate. Okay, here's proof of what we just calculated. Here's 50 degrees. Whoops. Here's 50 degrees, and the solubility is up at about 80 something. Okay. There's potassium nitrate. We just calculated that, and I think we found it was 88.3, and it's about 88 or 89, something like that. Here's something unusual. This is cerium sulfate, cerium 3 sulfate. And if you look at it, its solubility drops with temperature. That's interesting. That's unusual. If you look at all of the other ones, they are all going up. Some are going steeply, some less steeply, but they're all going up. So most solids go up, some don't. Now, if you want to write something down, here's what we're going to write down. These are the things that you need to know. Firstly, that some are just more soluble. That's obvious. We said sodium nitrate is very, very soluble, but calcium chloride overtakes it, but potassium nitrate never catches up with it. Secondly, in general, they become more soluble with temperature. So things dissolve better when it is hotter. The third point is that you need to know that it is always in grams of the solute or the salt in grams of water, in 100 grams of water, sorry, in 100 grams of water. That's what you always have to convert it to. So you can't leave that last one where we had it was, I can't remember, 26.5, I think, in 30. You can't just leave it that 26.5 grams of potassium nitrate dissolves in 30 of water. You have to work it out in grams per 100 of water. Above any particular line, it is what we call supersaturated. So if I look at potassium chloride here, the dark blue line, potassium chloride, if I look at a temperature like, let's say, 30 degrees, at 30 degrees, the solubility of potassium chloride looks like about 36 grams. If I put in 40 grams of potassium chloride into the water and it seems to disappear, then it is what we call supersaturated. On the line is saturated, that is the maximum amount. Under the line, it's more dilute. It's just a solution. And the final thing is that we can find out the solubility of a solid and work out how much will come out of solution or precipitate as we cool it down or warm it up in cerium's case. Okay? All right. So let's look at a question which is typical KCSE question for this sort of part of the syllabus. So they often ask you to use one of these graphs. They don't give you a mixture like this. They give you just one. I'll give you an example that I will go through, and then you can do one yourself. So here we go. Has everybody got that? Is it okay if I move on? People still writing? Can I move on? Cool. I'm moving on. Okay, here we go. So here's a question. What is the solubility of KNO3 at 50? We know what the answer is, but we'll show it. And then part B, if a student had 50 cubic centimeters of the solution at 50, how much would be precipitated if it was cooled to 20 instead of 50? So we'll look at this question. Okay, so we'll look at this question. I'll go through it. If you want to have a moment just to look at it and think, just have a look now. So just have a look at the question, look at the graph, even though you can't actually draw the lines you need to and so on. Just have a look at it and have a little bit of a think, talk with the person next to you, see if you can work out what the answer is approximately. You don't have the graph in front of you, so just have a bit of a look. What is the solubility at 50? And then if they took 50 cubic centimeter of solution and cooled it down from 50 to 20, how much would come out of solution? Just have a look yourself at the graph just now. Come on, Sir Michaels, you can do this. Come on, Kabiro. Wamwini can do it. Look at them. They're there. Come, Mathari Mixed. Of course you can do it. Just have a little bit of a write down, see if you can work out what the answer will be. And then I'll show you how we do it. And then you can do one. I'll give you one which you can actually do yourself. So people got some answers? I'll go through it and then you can see whether you're right. Okay, this is how I do it. So I'm going to look at the first bit, which is question 1A. What is the solubility of KNO3 at 50? Well, I think you can guess. I just draw a line from 50 up to the curved line and across, and that tells me it's around about 90, according to this graph here. The graph that they give you in the examination is the one that you should use. So even if you know the answer is 88.3, then just use this graph. Okay, so the simple thing, it's about 90 grams of KNO3 per 100 grams of water. Now, the second bit is if they started with 50 at 50 and they cooled it to 20, how much will they get out? Well, obviously, they're going to go with the first bit. Here's my 90 at 50. And here I then write another one for 20 degrees. And 20, it looks like 34 or so. 34, something like that. And therefore you think, well, it must be the difference between those two. And the answer between those two is 90 minus 34, which would be 56. Is that the right answer? Is that the right answer? Did anybody get that? Did you get that 56 or about that? Is it the right answer? Look at the question. Here we go again. Here's the question again. Look carefully at the question. Look at the question. Careful, look at the question. So we think the answer is 56. Everybody look at the question, please. Come on, Wamini, concentrate. I'll tell you that the answer is not 56. Why not? Surely I've got it right. Look, I say, there it is at 50, it's 90. At 20, it's probably 34. So 90 minus 34 is 56. Ah, look at the question. It says if you look at the question, back at the question, it said, if I start with 50 cubic centimeters of water, half as much. So you did the right thing. If you got about 56, you did the right thing. 90, 34, 56 difference. But the last half a mark will be for going, it's not 56. I only have half the solution. So it's actually 28. Okay, here's a similar problem. See if you can work out this one, okay? Here's one I'm going to give you and give you 5 minutes or so to have a look at. The question is, how much CuSO4? Oh, sorry, I think part of my screen is covering yours. Let's just see if I can get rid of it. Oh, I can't. Okay. If I cool 100 grams of saturated copper sulfate, okay, I'm starting with 100 grams of saturated copper sulfate, and I cool it from 80 to 30. I'm sorry, my picture seems to be in the way. It's from 80 to 30, and I'm starting with 100 grams. See if you can do that one. So how much CuSO4 will precipitate out if I cool 100 grams from 80 to 30, okay? 80 to 30. I'm sorry, if on your screen my picture is in the way, I'm sorry about that, but it is 80 to 30. So have a look at the graph. See if you can read it off. It is difficult. It would be much easier if you had a printout, but just see if you can read it out. Wow, 32. Quickly. Mathari, you are very fast. Okay, well, we'll see if you're right, won't we? We'll see if you're right. Who was that? Put your name on that, please. Mathari? Joseph. Okay, Joseph. Joseph thinks it's 32. Let's see if Joseph is right. Well done, Joseph. Let's see. Let's see if you're right. Everybody else. Joseph from Mathari Mix reckons it's 32. Let's have a look. Remember, it's from 80 to 30. Oh, hang on. Sorry, one more. Hang on. Let me just see. Hang on. Let me just have a look. I have to make my screen a bit bigger again. There, this person reckons it's 35. It's very difficult to tell. What's your name, please? Wamoini? Put your name down, please. So Joseph reckoned it was 32. And Gladys, who we have come across as a brain box before, thinks it's 35. Well done, Gladys. Very good. Also, Mary's has another answer. 58 minus 23 is 35. So Mary's has another one of 35. Oh, now we have two 35s and one 32. Joseph might be thinking, I wonder, have I got it right? Have I got it right? Oh my gosh, this is really testing. What could I do? Okay, should we have a look at it? Here are the numbers. This is what I do. So I draw the line up from 80 and then across, and that looks like about 58. And from 30 across, and it looks like about 22 or 23. 58 minus 22 or 23, 23 probably, is 35. Okay, now it's not possible. And obviously, in an examination, you would get that right because you would have your own copy of it. It would be much easier. It is, Joseph was in such a rush that he went 32. He's not wrong. He wouldn't have got it wrong on in the real examination. Okay, so we can move on. That's good. So here we go. Now, there are some things which it tells you in the syllabus that you need to know. And I'm going to tell you about this now. The first thing is you need to know the solubility curves, and I'm going to ask you to sketch them so you can remember them. You can sketch them all on the same axis of sodium chloride, potassium chlorate, 5, excuse me, calcium sulfate, and sodium carbonate. You need to know about something called fractional crystallization. You need to know about trona and sodium carbonate and about salt. Now, trona, what becomes sodium carbonate and sodium chloride are both produced in large quantities in Kenya, which is why it is in your syllabus. So let's look at these curves. I suggest you just sketch them on the same graph. Okay, so here we are. So sodium chloride looks like that. Sodium chloride is basically a straight line, and it's a lot lower than potassium nitrate. So you can just go, hey, it's a straight line. Sodium chloride. Okay. The next one is potassium chlorate. Now, potassium chlorate is a curve. It starts at just a little bit higher, sorry, a bit lower than the sodium chloride, but it goes up much higher. So potassium chlorate is much more soluble as it gets hotter. All right, that's important. So I'll sketch you them in just a minute. The next one is calcium sulfate. Oh, sorry, did I mention calcium sulfate? Yes, calcium sulfate goes down. Now, if you look at calcium sulfate, its solubility is very low to start with, but it goes down. That's very important. And then finally, sodium carbonate. I found this from a French site, which is quite interesting. Excuse me. And it does the same sort of thing as potassium chlorate, but starts a little bit lower and then drops again. Okay. So I'll show you what those look like on a graph. Oops, sorry. Let me find a plane. I'll draw them all on this one. I'll see if I can draw onto this one. Let me just see. So on this one, potassium chloride goes sort of like that. Okay, that's the potassium chloride. The potassium chlorate we've got there. Calcium chloride is right down here. It starts really low and it goes really, really low and down. That's the calcium sulfate. And the last one, which is the sodium carbonate, goes from if you look back on it, if we look at the question here, the sodium carbonate, it goes up and then down. Okay, so in other words, it starts quite low, but it then goes up and then it goes down a bit. Okay, so those are the shapes that they are. And I think it's worth you drawing them all, whoops, C03, all on the same curve. I'll answer your question in just a minute, St. Michael's. I saw your hand go up. Thank you very much. I'll answer your question in just a moment. They don't have to be accurate. What you've got to know is the shape of them. Sodium chloride increasing, straight line. Potassium chlorate very steeply rising above the sodium chloride. Sodium carbonate goes up so far and then decreases. Calcium sulfate hardly soluble at all and dropping. Let's look at them all again. Sorry, there's the sodium chloride compared with potassium nitrate. Sorry, the blue line there is the potassium chlorate. Calcium sulfate, look at these numbers here, 0.8, less than 1 gram in every 100 grams of solution. And sodium carbonate starts at about 5, goes up to about 35 at 40, and then drops a little bit. Not a lot, but a little bit. Okay, so Michaels, you had a question. Do tell me what the question is, please. Do you want to?
Can you pardon on the solubility of calcium sulfate?
Can I do what? Sorry.
Pardon on the solubility of calcium sulfate.
Can I show you it?
You pardon.
Do
Repeat.
you want me to explain it or do you want me
Yes.
to show you it?
To explain it.
Okay. Calcium sulfate is almost completely insoluble. I'll draw a little picture which will help to explain this. Let me just let me get back to this. Right, I'm going to find a blank page so I can show you. Where's a blank page? Okay. So when something like sodium chloride dissolves in water, goes from solid to sodium ions in water and chloride ions in water, then two things have to happen. Firstly, we have to break the solid, and then it makes new bonds with the water. Now, when calcium sulfate tries to dissolve in water, this is so strong that it is very difficult to happen. So, if I look at a graph of energy for sodium chloride, if I have sodium chloride here, this is sodium chloride solid, and I try and break it and then turn it into sodium ions and chloride ions in water. This is energy up the side. I have to put energy in and then I get more out. So it is more stable afterwards. Okay? With calcium sulfate starts at about the same place. Let me just get rid of this. Let me just get rid of what I've got at the moment. Okay, so calcium sulfate starts here as solid, and if it could dissolve in water like this, it would produce calcium ions and sulfate ions in water. But because this is so strong, the energy that we would have to put in is so huge that it doesn't happen. And therefore, it is hardly soluble at all. So in other words, when we look at solubility, there are two things that have to happen. We have to be able to break up what we call the lattice, that is the solid, and then add it to water. The calcium ions and the sulfite ions are very good at adding to water, but they can't get away from each other. That is why calcium sulfate does not dissolve in water properly. So when we look at when we look at this graph, it is only not really soluble because it cannot break up properly. Does that help? Does that help explain? Cool, excellent. So whenever things dissolve in water, they have to break first, and then the water helps them. But in calcium's case, the calcium and sulfate love each other so much. No, they are so attracted towards each other that it takes too much energy. Okay. Now, here is a question, and it's about something called fractional crystallization. And the question is, how could you separate if you had 40 grams of sodium chloride and 150 grams of potassium nitrate? How could these graphs help you? Well, if you look at 150 grams of potassium nitrate, that's here, over on the left-hand side, and you look at the sort of temperature at which it would dissolve at something like 80 or something like that. Okay, see that? It go down 75, 80, something like that, 70, 70, somewhere between 70 and 80. 40 grams of sodium chloride would dissolve at about the same sort of temperature. So to separate them, so somebody gives me a beaker, a cup with 150 grams of potassium nitrate and 40 grams of sodium chloride, and I put them in some water. I put them in 100 grams of water. There's my 150 grams of potassium nitrate. It dissolves at 76 degrees Celsius. Here's 40 of sodium chloride. It also dissolves at 76 degrees. So what I do then is I heat them both up. I put them both in the same water, heat them up to 76 degrees Celsius. What will happen if I start to cool them? What will happen if I start to cool them? Well, potassium nitrate, as I cool it, most of the potassium nitrate will stop being able to be soluble in water down until I get to a temperature of about 24 degrees Celsius. Potassium nitrate should be way more soluble, but its maximum solubility we found of 150 grams was at 76 or so, 77 degrees Celsius. So if I cool that down, what will happen is that potassium nitrate will come out of solution until at 25 or so, there is only about 40 of it left. In other words, I have got rid of 110 grams of potassium nitrate. You see, it has gone down from here down to there. Whereas the sodium chloride has almost stayed in solution. It has gone from around about 40 down to, not much, 38, something like that. So in other words, I have separated 110 grams of potassium nitrate from 2 grams of sodium chloride. That is what we call fractional crystallization. So you find a temperature at which both of them dissolve, but using the greater solubility of potassium nitrate, I can now cool it down until the potassium nitrate is coming out, but the sodium chloride is basically still in solution. That is fractional crystallization. Okay. So fractional crystallization works like this. If I have two salts and one is much more soluble than the other one, I look on their solubility curves and I find a temperature at which they both dissolve however much I want. And then I allow them to cool down so that only one of them comes out of solution. Okay, so I let them cool down. So in the potassium nitrate, much more soluble at, let's say, 100 degrees Celsius. And I can let it cool down, I can let it cool down until the sodium chloride is still in solution, but the potassium nitrate is coming out of solution. And that way I am getting the potassium nitrate to come out, but the sodium chloride is left in the solution. Then I can do it again. I can put some more potassium nitrate in, and potassium nitrate and sodium chloride. And this time I can heat it up again, cool it down again, and each time only the potassium nitrate is coming out. Right, the last thing we said we would do is to talk about the uses of solubility. And next time we will look at trona, and we will look at salt and what we call washing soda, and how we make those two, how we get those two out of solution. At Magadi, Lake Natron, and up on the coast, up just south, no, just between Malindi and Lamu. There's a place where salt is mined from the sea, and we will look at those two processes next time. But now we're just going to run back over the whole presentation, and hopefully it will now make a bit more sense than it did at the beginning. So I'm now going to go back, share my screen. So this is what we have done, which is quite a lot, really. So the first thing you need to do is to know the definitions. Do test yourself with the definitions, or test your friends with the definitions. Okay, that was important. Then we had to do the calculation of solubility. And it always has to be in mass of solute per 100 grams of solvent. So we did an example and we said, okay, we need to work out the mass of water and the mass of crystals. And there are two different ways of doing it. But in this, if I wanted to work out just the mass of water, I could say, okay, 85 minus 61 will be the water, and 61 minus 55 will give me the crystals. Then what I had to do was to work out, I can't remember the numbers. Let me just have a look. 624, right? So we ended up with this in 6 grams in 24 grams of water is the same as I don't know how many grams in 100 grams of water, which is what I need to do. Then I cross multiply these. So I get 24x equals 600. So x is 600 divided by 24. And that's how I do it. Okay, that's how I work out the whole thing. You had an example. Then we looked at the solubility curves. There are not many you need to know, but you need to know about things that in general, oh, sorry, I've got to get rid of all this ink. Sorry, just one moment. My apologies, it'll all be gone in a minute. Here are the things which you needed to know about solubility in general. Some are more soluble. Most solids become more soluble as temperature increases. I said most gases become less soluble. The measurements are always in grams of solute per 100 grams of water. And we can find the solubility by just drawing a line up. Then we came across an example of this. There's the solubility at a particular temperature. Here's how you find two different solubilities there. That should allow us to work out how much will come out of solution. But we had a trick question because in the question it said not 100 grams of water, but 50 grams. Here's the question again. There it is, 50 cubic centimeters of water, not 100. And therefore, instead of it being 56, it's 28. Be careful of that sort of thing. You had an example, which you did very well indeed. Then here are the solubility curves. We talked a little bit about fractional crystallization. There's their shapes, roughly. Sodium chloride straight across, potassium chlorate upwards, sodium carbonate up, then down, calcium sulfate almost insoluble, almost insoluble. And then we saw that if we start with a lot of potassium nitrate and a smaller amount of sodium chloride, we can separate them as if we heat it up to a certain high temperature and then let it cool down, but the potassium nitrate comes out of solution and the sodium chloride stays in, and therefore we separate them. Okay, so that is just about exactly time. I hope that was useful. It is recorded. I'll stop recording now.